Alright, this is Chapter 3, Section 5. This is the third video. So this is the last page, which is comparing tree and Venn diagrams. They're both probability. Essentially, they have to have the same outcomes and numbers. They're related to each other, right? So essentially what we have here is items coming off a manufacturing line, right? An item manufactured at a specific factory has a 20% chance of being built defective. The quality inspectors at the same factory do not take their jobs seriously and mistakenly misclassify the items coming off the line. They either put a good or defective or good sticker on every item coming off the line. So essentially when you manufacture something, it's either good or defective, and the inspectors put stickers on them, so hopefully the bad ones get pulled. But not always, because 95% of defective items are classified as defective, and 10% of the good items are classified as defective. So that's not good. That means we have some mistakes here, correct? So I can do probability of not defective, right? And I can go the other way and do the probability of defective, because they're either going to be manufactured good or not, right? So what we're saying here is 80% of the items are good in this factory, which I would not think that's a very good thing, which means 80% of the items, or I'm sorry, 20% of the items are did I get that backwards? No, I got that. So defective items 20%. So that's not good. Okay. So at that point, you're going to have one of two things. They're either going to be labeled correctly or not, correct? So probability of being correctly labeled or not correctly labeled, right? And this is under the condition they were not defective to begin with. Right, not defective to begin with, versus being correct or not correct, but they were defective to begin with, right? Alright, so if I look at my numbers here, it says 95% of the defective items are classified as defective. That's what should happen. So defective items labeled correctly would be 95%. That's what should happen, which means 5% of the time those defective items are not labeled correctly. And it says 10% of the good items are classified as defective, which is not what should happen, right? So that means that's incorrectly labeled 10% of the time if they're good items, which means 90% of the time we're good, essentially, right? Alright, so I multiply through all these paths, I'll get the ands, and then they should add up to 1, which we'll do afterwards, essentially. We can do that now. So this times this is going to be 0.72. This times this is going to be 0.08. This times this is going to be 0.19. This times this is going to be 0.01, right? So this is the probability of not defective and correct, right? This is the probability of not defective and not correct, right? This is the probability of defective and correct. And this is the probability of defective and not correct. Those are the four. And what you notice is this adds up to 1, doesn't it? Okay. Alright, so I made this ahead of time. I'm going to paste this in here. And my numbers I put ahead of time. Okay, so when we make the Venn diagram, it should be the same thing, right? So if I draw the Venn diagram, right, you can be both at the same time, correct? So I am both. So I'll do D on this side, and I'll do C on this side. And I could switch it C or D, D or C. Don't be the person that says good or bad and makes 2 circles. Don't say correct or not correct and make 2 circles. That would make a Venn diagram that's 4 circles. You could do that, but that would be miserable. Don't do that. Use the least amount of variables possible and do something or not something using the line above it, essentially. Okay? Okay, so if I'm both, that's 19%. Right? If I'm neither, that's 8%. Okay? If I'm C but not D, right? That's this one here, isn't it? It goes there. If I'm D but not C, that goes here, doesn't it? So the same numbers from the tree are the same numbers in the Venn diagram, okay? All right, so let's copy over here real quick. Copy. Paste. Okay, oop, got a little bit of problem there, but that's okay. All right, so this circle is C, this circle is D, or you can switch them, right? So this is D and not C, this is C and not D, this is both in the middle, and this is neither on the outside, correct? Okay. So the entire circle is C, the entire circle is D when you add them together, right? All right, so let's look at the questions that it's asking. We can use either one of these to answer the question. Okay. So it's saying, let's get this out of the way. You purchase an item with a sticker classified as good, then what's the probability of the item not being defective? Okay, so probabilities are fractions, right? Okay, so purchase an item with a good sticker on it. So let's think about the good stickers, right? So if I'm not defective and I'm classified correctly, I'd have a good sticker on it, wouldn't I? It's a good item, right? Not defective. It's classified correctly, so it says that it's a good. It has a good sticker, right? That makes sense. However, what about these? It's a defective item that's not labeled correctly, which would mean to have a good sticker. So these also have good stickers, don't they? So essentially, you have 0.72 and 0.71 that have the good stickers on them, right? But I want to know the probability of having one that's not defective. Only those ones are not defective, right? Because they have good stickers on them and they're a good item, right? But like, what about this? Well, they're defective and labeled correctly. Those would never get shipped to the store because they have bad stickers on them, right? The sticker says bad because it's a defective item and it's labeled correctly. They didn't go to the store. So essentially, the probability of purchasing an item that has a good sticker on it is 0.7272 over 0.73, right? Or essentially 72 out of 73. Okay? All right. Let's think about the other question here. Determine this conditional probability. Classified correctly and defective. So you don't tend to find that in the Venn diagram. You could figure it out from it, but that's extra work. Just use the tree diagram. So this is the probability of C given D, isn't it? That's just one of the branches because it's a conditional probability. That's this right here, 95, correct? Okay. So all we have to do is this. Okay, and the last question is asking, what's the probability of purchasing a non-defective item? Well, wait a minute. We already answered that. Because if you get a good sticker, that's the same thing as a non-defective item. Because you wouldn't have gotten these ones in the store anyways, right? So it's asking the same question in a different way, essentially. No difference. Okay? So, long story short, the tree and the Venn, they're the same thing in different contexts. The tree gives you a little bit more information because it has the conditionals of how to get those items, you know what I'm saying? But essentially it's just two different visuals for the same exact thing.